Hello everyone, welcome to our TESOL Global YouTube channel. This is our tutorial video series where we will give you different tips and tricks of designing and testing of different circuits and devices. In our previous videos, we showed how you can use multimeters to measure voltage and current in a circuit. We received a lot of requests to explain the theory behind calculating voltage and current in such circuits. So in coming few videos, we will discuss the theory of calculating voltage and current in circuits. To start with, there are different theories to calculate voltage and current in a circuit, such as Ohm's law, Kirchhoff's voltage law or KVL, Kirchhoff's current law or KCL, voltage divider rule, current divider rule, and node and mesh analysis. So we will consider these circuits for all of these theories. Out of these theories, Ohm's law, voltage divider rule, and current divider rule are the most popular and very frequently used theories. Here we are considering the same circuits we used in our previous videos. Here you can see the circuit with a DC source and two resistors are connected in series. We use this circuit to show how to measure voltage with a multimeter. You can find the link of that video at the top side of this video. Next, you can see another circuit with a DC source and two resistors are connected in parallel. We use this circuit to show how to measure current with a multimeter. You can find the link of that video at the top side of this video. In today's video, we'll mainly discuss Ohm's law. Now, to move on to the next part, Ohm's law states that electric current I through a conductor between 2 points is directly proportional to the voltage V across the 2 points. So we can say V is proportional to I, or you can write V is equal to I into R, where R is the proportionality constant. Now the first circuit as an example has a DC source VDD and two resistors R1 and R2 in series, where we are considering R1 resistor. Here V1 is the voltage drop across the R1 and I is the total current of the circuit, where I1 is the current flowing through R1. Here I1 and I are the same current. Now if we consider a constant resistance of 5 ohm at R1, then if I1 is 1 ampere, then V1 can be calculated as 5 volt from the Ohm's law. Next, if we increase I1 to 2 ampere, then it will give us V1 as 10 volt. Next, if we increase I1 to 3 ampere, then it will give us 15 volt from Ohm's law. Therefore, we can see a proportional increase of V1 with I1. Next, with the same Ohm's law, we are considering the second example circuit, where it has a DC source and two resistors R1 and R2 in parallel, where we are considering R1 resistor. V1 is the total voltage drop across R1 and I is the total current of the circuit, where I1 is the current flowing through R1. Here I1 and I are not equal. Next, if I2 is flowing through R2, then the total current of the circuit I will be I1 plus I2. This current can be calculated from KCL or Kirchhoff's current law, which will be discussed in our next video. Again, if we consider a constant resistor of 10 ohm at R1, then first we will rearrange the Ohm's law and we will write I is equal to V by R. Then if we have V1 as 10 volt, then it will give I1 is equal to 1 ampere, which is calculated again from the Ohm's law. Now if we increase V1 to 15 volt, then it will give us I1 is equal to 1.5 ampere. And similarly, if we increase V1 to 20 volt, then it will give us I1 is equal to 2 ampere of current. So therefore, again, we can say there is a proportional increase of I1 with V1. So this is the end of this video. In our next video, we will explain Kirchhoff's voltage law or KVL and Kirchhoff's current law or KCL. Please subscribe to our channel for more videos like this. We'd like to thank those who already subscribed and helping us to grow our channel. Add likes and comments and give us suggestion of what kind of video you want us to make. Follow us on LinkedIn, Twitter or X and in Facebook. Thank you for watching. See you next time.